Hello everyone, I'm happy to announce chapter 3 is ready for you, and I figured I might record a little intro video to walk you through the material to help you, because it is 60 pages and there's a lot of stuff going on, so I figured a little video intro might be helpful. So remember, this is the page where you can find all the excerpts. I assume you've read chapter 1 and chapter 2, and this is the new stuff, chapter 3. We finally get to statistics. So this is the overall map for the book. In chapter 1 we talked all about data management, collecting descriptive statistics, and in chapter 2 we learned probability theory. So now it's finally coming together to talk about statistical inference. So this is what this chapter is all about, and yeah, so let's get started. So this video will just give a quick overview of what statistical inference is, and then we'll talk about estimators in the next video. Okay, so what is the general story is the following. So probability theory tells us how data is generated. So imagine here you have some probability model, like the normal distribution, and the normal distribution takes some parameters, for example the mean and the variance. So we call those model parameters. I'm going to use theta as a generic name, because for exponential distribution you need lambda. For uniform distribution you have different parameters. So without getting, instead of discussing one specific model, I'm just going to call it any model and any parameters. So probability theory tells you how, given the model parameters in the model, what data you can observe. So this is the forward arrow here. And statistical inference, or inferential statistics, is reverse engineering this process. So you have observed some data, you know the model, and the question is, what are the model parameters that the likelihood of different model parameters that could have created this data. Okay, so a little bit what is different from chapter 1. We did similar things, right? We analyzed data and we looked at the properties like the sample mean, sample variance, but we were really trying to describe the data, giving me a summary, what is the sample mean, and so on. There was no wider population. We were just focused on one sample. So this is the new thing here, is that we assume this sample came from some wider population. And that's what statistical inference is. It says, like, what can you learn? You've just looked at one sample and you want to know what population did it come from. Okay, so here is a particular example. If I can enlarge this a little bit.
It's 11 o'clock.
There is a population of weights, so the data about 1 million individuals, and the weight is assumed to be normally distributed, and there are unknown parameters. So the average weight in the population and the standard deviation is the width of this curve, but we don't know this. Like to obtain this distribution, we would have to measure 1 million weights, the weights of all the individuals in the population. That's prohibitively expensive. Like, you would have to do remember, that's called a census, when you measure all the whole population. Instead, what we have is just a sample from that population. Here, this example, I'm saying there's 100 weights, and we can plot a histogram of the sample, and you see these are the weights in the sample. So how can we, so statistical inference, the whole point is to say, use the data in the sample to learn about the parameters of the population. And intuitively it's very simple. Like, look where the center of this distribution is. That's the sample mean. Well, that's kind of tells you a little bit about the population mean. And similarly, the width of the sample, like the standard deviation of the sample, tells you about the standard deviation of the population. So that's, in a nutshell, that's what statistical inference is. We take the properties of the sample in order to infer. I call it somewhere educated guessing. But yeah, so this process here is like try to guess where this sample came from. And the reason why this is possible is because we assume the probability model for the population is a normal distribution. So this is one of the key steps, is that we assume this process is a normal distribution that created this, and that's what allows us to then do reverse engineering to find the population. Okay, and yeah, so here is the sample mean. It's an estimate for the population mean. And here's the sample variance, is an estimate for the population variance. Okay, there's a lot of questions that we're skipping in this high-level description. You know, what is the sample size? How big? Here we gave an example with sample size of 100. Would a sample of size 50 been enough? Or maybe we needed more, larger samples. And if you guess, so we said the sample mean is approximation for the population mean. I mean, how good is this approximation? So we'll learn how to quantify that. And yeah, and so later on in the chapter, we'll do other things like hypothesis testing and all that. But the fundamental idea is this: we have sample. What can you tell me about the population where that sample came from? Okay, so we start with the estimation process. This is what will be in the next video. And later in the chapter, we'll talk about other like hypothesis testing and other applications. I mean, statistics, look at that. There's a bunch of stuff here. So today we're just going to discuss the what I like to call the math machinery. Okay. Little heads up. Yada yada yada. Yeah, statistics is useful. I don't think I need to tell you that. What can you do with statistics? You can compute confidence intervals. So when you make an estimate of the population mean, you can actually say, quantify how uncertain you are. Hypothesis testing is when you're like, is the mean greater than some threshold or not? And that's what you see in science papers, and I mean, statistics is useful, yada yada. Okay, so it's not going to be easy. So this is the deal. I want you to really understand statistics. So I'm going to give you all the math details, and I'm going to basically, if you try to do a shallow understanding of statistics, just memorize some formulas, you can get through all this material in much faster. And the problem is you won't understand what's going on. So we're not doing the shallow thing. We're going to go deeper by really understanding what are the math assumptions, what is how can I say this? What's going on under the hood? Okay, so this is the deal. No bullshit guide means you will suffer. You will suffer mathematically. You'll be exposed to math. Both math equations and code examples. So we're going to go really deep in this. Okay. The benefit is, well, there are two things. So first of all, the fact that you know about data and probability models will make this possible. Like, this is why you did all the work in data and probability, because I wanted you to be able to handle the real stuff. And the second part is that once we get through the statistical inference math machinery, all the applications like estimation, confidence intervals, hypothesis testing, and linear models, all of these will be simple application. Like you will be a little uphill now, but after that it's all smooth sailing. It's all going to be super easy. Okay, so here is the learning objectives. You can read in the PDF. And we're ready to start with estimators. All right, next video.